All right, section 1.2, use segments and congruence. Our objective is to use segment postulates to identify congruent segments. First up, we've got a bit of an algebra review. We are asked to solve this equation. First thing that we did to solve this. Ariana? That's one way of doing it. I simply want 3 words. 3 words is all I'm looking for. Oh, let's see. Well, now this is hard. Is it Ariana? Okay. Yes, Rodney, do you have my 3 words?
Combine like terms.
There we go. Combine like terms. So just in general, the first thing we need to do is combine like terms. Yes, that does involve adding and subtracting. Yes, you could do your inverse operations to both sides first, but I would recommend just combining like terms first. What is like the 3x? Anybody? 2x, thank you. When we add those, what do we get? There we go. And I believe it was already said the 5 and the minus 4 are like. When we combine those, what do we get?
1.
Plus or minus 1. There we go. Now that is not the only way you could start that problem, but that is how I would recommend doing it. Combine like terms first. Now what do we need to do? Subtract the 1, and last thing would be divide by 5. Now, this is not Algebra 1. This is geometry. So, if you were to, let me make that a little more visible. I do expect to see some work. I don't necessarily need to see everything. So, what that means is that if you were to not put minus 1, and you didn't put divide by 5, in this class, that's okay. I still need to see your steps, and you still need to just do one thing at a time so I can follow along. But if you don't have to write it out on both sides, I get it. We're a little beyond that now. We're in geometry, not Algebra 1. In our notes, again, it's geometry. We're a little heavy on the definitions. A postulate, or also called an axiom, is a rule that is accepted without proof. It's something that we just say, yes, I understand that that's true. There's not really a great explanation for why, but it makes sense. Kind of like 1 plus 1 equals 2. It's hard to really prove that, but we just accept it. A theorem, however, is a rule that can be proved. A rule that can be proved. A coordinate is the real number that corresponds to a point. Right below that we have a note. When 3 points are collinear, meaning that they lie on the same line, you can say that 1 point is between the other 2. Distance is the length between 2 points, or just the distance between 2 points. It is always a positive number. It's always positive. Now, the formal definition for distance is a little bit wordier. So if you were to look in your book, it's going to say something like the absolute value of the difference between the coordinates. That's really wordy. It's just the length between them. All right, congruent segments are line segments that have the same length. Congruent is a word that we will use a lot. So we have a symbol for congruence. I know we're all brand new to geometry, but has anybody seen the congruence symbol before? Know what it looks like? That's close. We're going to combine those two ideas. It's an equal sign with a squiggly bar on top of it. Now, if you have just a squiggly alone, that means something different. We'll talk about that later. If you have two squigglies, like a squiggly equal sign, that actually means approximately. So we are a little bit picky about our equals and our squigglies in this class. So anytime you see an equal sign with the squiggly on top of it, that means congruent. All right, first up we've got the ruler postulate. The points on a line can be matched 1 to 1. 1 to 1 with real numbers. The number that corresponds to a point is the coordinate of the point. We already talked about that definition above. That really is nothing new. That really just means we're talking about like a number line or a segment. Every point on the line is assigned to one number. That's what the whole 1 to 1 means. Questions about that postulate? Again, a postulate is accepted without writing a proof. So we just say, yes, I understand. Points on a line are each matched to one number only. We call those the coordinates. Our next postulate is a little bit more interesting, and it's one that we will use over and over throughout the year from time to time. If B, now remember that this capital letter is talking about a point, B, is between A and C. You can see that on the number line down here. B is in between points A and C. Then AB plus BC is equal to AC. It works the other way. If AB plus BC is equal to AC, then B is between A and C. Now, before we flip over and move on, we do have a little bit we need to talk about with this. Seems simple and straightforward, and it is, but our notation in geometry gets a little picky. Notice that I did not put a bar over these A, B, B, C, and AC. If there is not a bar over them, we're talking about their length or a number that represents them. If I put the bar over them, I'm talking about the figure or the object of a line segment. So right now, AB, BC, and AC just represent numbers, and that's why we write them in an equation. If it had the bars over the top of them, we would be talking about objects or figures, pictures, and pictures do not usually get put into an equation. So I know it's a little bit picky how we talk about it. Okay, so if we were moving on from the whole bar, no bar idea, this diagram down here helps us better understand what this whole AB plus BC equals AC means. Without the bar, we're talking about their length or a number. So for example, it might make more sense if we label these with some numbers. So if I were to label AB as having a length of 7, and BC as having a length of 8. Then what would that mean about AC? It's 15. How'd you get that? Because you add them together. That's why this is just a postulate. Don't think too hard about it. There's not much to it. I think most of you probably could have figured out AC if I'd given you AB and BC when you walked in the door the first day of school. So the addition postulate just says that you can take two segments and put them together and you get a bigger segment. All right, so at the very bottom of that front side, you should have a note. Goes along with what I was making a big deal about on the last slide. Lengths of numbers can be equal. Figures can be congruent. So as an example, if you want to put it up there, you could say something like AB is equal to AB. Now I know that doesn't mean a whole lot. Something's equal to itself. We'll talk about that later. But when we put the bar over it, we are now talking about it as an object, a figure, a picture. So when we put the bar over it and we're talking about it as a picture, that's when we use the congruent symbol instead of an equal sign. Numbers are equal, figures are congruent. We'll reiterate that idea over and over and over again. All right, the locations shown lie in a straight line. Find the distance from the starting point to the destination. Takes us longer to read the problem than to do it, most likely. Anybody have any thoughts about how to find the answer? Yeah. Good. So if we were to write out as an equation the length from our starting point to the rest area, SR, plus the length from the rest area to the destination, RD, is going to give us the whole thing from start to destination. Now, I'm not expecting that you would always write this out because it is as simple as just adding the pieces together. So we're going to add together 64 plus 87 to get the length from S to D. And what do we get? What did we get? 151? Okay, sorry, I thought I heard some twos thrown in there. So from S to D would be 151. My units are miles. Questions, concerns about how we did that? Okay. Should be hopefully easy peasy. Number 2, use the diagram to find KL. So they did not put a bar over the KL. That means they're talking about its length or a number. If it helps, we could set up an equation using segment addition. Meaning if I take the two small ones, JK plus KL, I should get JL. Add the two little pieces, you should get the whole thing. We were given a length for JK. What is it? 15. We were asked to find KL, so I'll leave it as KL. We were given a length for JL. What is it? 38. How am I going to get KL alone? close. Switch your numbers. 38 minus 15. We subtract 15 from both sides. Again, you do not have to write it all out. But for those of you that are unsure, I will write it on the board. So what do we get for KL? 23. They did not put units, so I'm not worried about them. Now on a quiz or a test, or especially when we move on and we're like on the final exam or something, I'm not expecting that you're going to write out every single line that I did up here. If you need to see it today because it's new, that's fine. But it is just as simple as subtracting a small piece from the whole piece to get another part of it. So don't overcomplicate it if you don't need to. Questions, concerns before we move on? Okay, here we go. Example 3 brings back our lovely coordinate plane. We are to plot these points. And our question is segment FG congruent to segment HJ? So when you plot your points, turn FG into a segment. Connect points F and G. Turn HJ into a segment. Connect the points H and J. And see if you can decide if they are congruent. All right, now I'm hoping we remembered how to plot points from algebra. Okay, so we move along our x-axis first and then along our y-axis. So I'm going to go ahead and just put the points up on my grid. I would make sure you're labeling them if you did not already do so. Ooh. G. And again, connect the segments that they're talking about. So connect G to F or F to G, and connect H to J. You do not have to connect any of the other points to each other. So I would not do that, otherwise that'll make this look more confusing. So what did we decide? Is FG congruent to HJ? Yes, why? Same length, good. So if it just says, is it, and you just put yes or no, that's fine. If they ask for an explanation, you would say same length. Both have a length of how many units? 5 units. Questions, concerns about number 3? Okay, if you're a little rusty on plotting points and you would like help with that, please come ask me during homework time and we can talk about it. All right, if you have not already done so, let's look at example 4. Now, if we were just doing this very simply like we did in our setup, then we would be writing out a statement like AB plus BC is equal to AC. And if you need to do that to understand what's happening, go for it. Small piece plus small piece equals big whole piece. Then we should plug in what we know about this. What did they label AB as having a length of? Good. Plus BC equals, beautiful. Ooh, forgot my X. What do I need to do to solve this? Combine like terms. 4x plus 12x gives me, beautiful. Last step to get x alone. What do we get for x? 2. Now I would be careful on questions like this because we found x, so are we done? No, they didn't ask for x. What did they ask for? AB. Don't do 90% of the problem and then forget to answer the question. If you just find x, and this is a test where it's open response and I'm grading it, you'll get partial credit. But if this is on the final and you just get ahead of yourself and say, oh, the answer is 2, 2 is an option, fill that bubble in, you're getting the whole question wrong. Even though you clearly knew what you were doing, you just didn't read the question. So what is AB? How'd you get that? Beautiful. No, you do not need to show that, but for those of you that want to see it, we're plugging x back in to the AB portion, which was 4x to get AB equals 8.